Hello guys, my name is Sanjeev Reddy and welcome back to Statistical Academy. In this video, we are going to be talking about the creation of frequency reports and summary statistics reports. So let's get started. Don't forget to hit the subscribe button and leave a comment with your thoughts on the topic. Let's learn together. The links for the program and the example datasets I use in this video are in the description below. By default, each variable listed in the table statement of PROC FREQ generates a separate frequency table that includes the number and percentage of observations for each value in the data, as well as a cumulative frequency and percent. But PROC FREQ can do much more than simple frequency reports. There are options that you can add to the PROC FREQ statement and options you can add to the table statement that you can use to customize the output and include additional statistics. You can create a report that shows the number of variable levels, specify statistics, and the order rows appear in the results, and create graphs to view the distribution of column values. In this demo, we will look at the PROC FREQ and the many options that are available to customize our output. We will start with the default PROC report. So notice I'm beginning with the PROC FREQ data equal to practice.heart data, and I'm using the table statement to indicate the variables that I wanted to analyze: treatment and age at start. So let us take a look at the initial report. There is a separate table for each of those two variables. We have one row per the treatment, and the report includes the frequency counts, percent, and cumulative frequency and cumulative percent, and the same way for age at start. Well, what else can we do to customize this output? We can come back to the code tab and start with the options order equal to. So by default, the report was ordered in the alphabetic or numeric sequence depending on the type of the variable. But I can instead use order equal to FREQ to sequence the report in descending frequencies. I will also add an option called N levels. Let us see what happens. So first of all, order equal to FREQ has changed the sequence of the report. The treatment with the highest frequency is at the top of the report, and then the remaining rows are in descending sequence. The N levels option added this table at the top. It tells us that for the variable treatment, there were 5 unique values, and for age at start, there were 35. Let's go back to the program and try some other options. On the table statement, after a slash, there are several different options that I can provide in order to customize the statistics that are included in these tables. If I wanted to eliminate the cumulative columns that are cumulative frequency and cumulative percent, I can simply type no cum. You will notice that cumulative columns are eliminated. Well, what if I analyze a slightly different variable here? I will keep treatment in the table statement, but instead of age at start, let us analyze start date. Now if I run the program as is, the frequency report for the start date is not so interesting. It tells me how many treatments occurred on each unique date, and it is a pretty long report. Instead of this, what if I would like to group the data based on date? For example, I would like to find out how many treatments occurred in each month of the year 2020, because all of the treatments for this clinical study were carried out in the year of 2020, and I don't have separate variable for the month. Can I do this without computing a new variable? And the answer is absolutely. We can take advantage of formats. So back in the PROC FREQ step, I will add a format statement and format start date, and I will use a MON name format in order to display the month name. And when I run this program, you will notice I have one row per formatted value, the month name, and we can see that most treatments occurred in September and August. Well, numbers are great. It is helpful to see these reports and look at the frequencies and percentages. But sometimes a picture or a graphical visualization is a great way to look at the distribution of your values. And this is really easy to accomplish in the frequency procedure. So I will come back to the program, and we are going to take advantage of something that we call ODS graphics. These are inbuilt graphics to certain procedures that make it very easy to create visual representations of the reports or data that we are analyzing. Before the PROC FREQ step, I do need to ensure that ODS graphics are turned on, and I simply do that with the ODS graphics on. This is a setting that once it turned on for your SAS session, it remains on for the duration of your session, and there is no reason to turn it off. On the table statement, after the slash, I will add an option to create a plot. So plots equal, and the type of plot I wanted to create is a freq plot. I could stop there and just create the default graph, but in parentheses, I could also add additional options to customize the appearance of our graph. A couple of options that I would like to use include orientation. So just the keyword orient equal to horizontal. And if we don't add these, the default would have been vertical. And the scale option by default would be frequency counts. Instead, I would like it to be %. So with the addition, let us run the program. And take a look at the bar chart that was created. Again, the numbers are helpful, but it is really informative to look at the distribution of treatment in this bar chart. So one more change. Notice we are still seeing this little extra title appear, the FREQ procedure. This is not a title we asked for, but there are several procedures that by default will show those titles. It is called the procedure title, and it can be turned off. To do that, I will come back to my program and add the statement ODS no proc title. This is also a global statement, so once I turn off the procedure titles, that setting will remain in effect for the duration of my SAS session. I will add a custom title, frequency reports for treatment names and treatment months. And remember, as a good practice, at the conclusion of my program, I will add a title null statement, and I will turn procedure titles back on for future programs that may be submitted. And I can do that with ODS PROC title. To further enhance the report, I will add some labels. So I will label the variable treatment as simply treatment name, and start date will be month of treatment. That's it. Let's check out the final result. So here is our final report. We have our title frequency report for treatment name and treatment months. The first variable that is analyzed is treatment. So we have the numeric frequency table as well as the bar chart. And if I scroll down a bit further, I have the numeric frequencies and percentages for treatment month as well as the distribution. And you will notice the treatment month label on the vertical axis. This little symbol in the table statement can make a huge difference in the results. When you place an asterisk between the two variables in the table statement, PROC FREQ produces a two-way frequency or a cross tabulation report. In this report, you can see frequency counts and percentages for a combination of values in the two variables. For example, you can see here that the frequency count for patients with high blood pressure and high cholesterol is 912, which represents 18.79% of the total. This is about 43% of all high blood pressure individuals and close to 53% of all high cholesterol individuals. A two-way frequency report can use some of the same options as the one-way frequency report, but there are additional options unique to the two-way frequency report that enable you to apply different layouts to the results or include new statistics or analysis. Let us check out some of these options in a demo. We have seen how to do a one-way frequency report using PROC FREQ, but simply by adding an asterisk between the variables on a table statement can create a two-way frequency report. Let's take a look at this step. On the table statement, we are analyzing treatment and start date. Treatment will be the rows and start date will be the columns. I will submit the program and you can see we have got a pretty big table. One row for each treatment and one column for each of the formatted values of the start date, which is the name of the month. The numbers within each cell represent the frequency percent and then a row percentage. So the row percentages will total across to 100%. And then a column percentage is the last value. So the last numbers within each column will total to 100%. We can customize the way this table looks and the numbers that are reported using options. So let me go back to the program. On the table statement, let us say I just want the table to include the frequency counts. So after the slash on the table statement, I can use no row, no column so that I will get rid of the row and column percentages. And then no percent will get rid of the overall percentage. And if I run the program, I am left with only frequency counts. So this is the default layout of the two-way frequency table. But there are other ways that the same information can be presented. I will change the options after the slash on the table statement and use a cross list. Take a look at the output. The same numbers are reported, a frequency percent and a row and column percent. But you can see it is arranged differently. We have the treatment and then within each treatment, each unique value of the formatted value of start date. And there is another option. Instead of cross list, let us see what the list option will produce. This looks little more like the one-way frequency report where we have the frequency percent and cumulative frequency and percent for each combination of treatment and formatted start date. Let's try one more thing. Till now, we have used PROC FREQ to create a report, but what if you would like to produce a dataset that contains these frequency counts or other statistics that you may use for further analysis? Well, that is not hard to do at all. After the slash, I can use the out equal option and name a dataset. I will call it treatments. If I wanted to suppress the printed or report, I can use the option no print. When I run this program, you will notice I have the output data that captures each value of the treatment and the formatted value of the start date, as well as a frequency count and percentage. The results tab is empty because I used the no print option. There are so many options that are available to customize the results you create with the PROC FREQ. We will explore them as we move on with our course. I encourage you to practice and explore the other options as well. The means procedure is great for calculating basic summary statistics, and if you are looking for invalid numeric values, might be outside of an expected range. But now we are beyond validation, and we can use PROC means to generate complex reports that include various statistics and groupings within the data. You have used the where statement in PROC means to specify the numeric variables to analyze. In the PROC means statement, you can specify the statistics that you want to calculate and how they should be displayed. The class statement enables you to name one or more variables to group the data, and then statistics are calculated for each unique value of the class variables. When you have more than one class variable, you can use the where statement to control the combination of values of the class variables. Let us see these new options and statements in a demo. Let's look at the default PROC means report and additional options that we can use to customize the output. So to start with, we will use the PROC means data equal practice.hot data. And the variable that we will analyze is cholesterol. I will run this program and we have statistics produced for the entire dataset. There were 4854 known values for cholesterol. The report includes the mean, standard deviation, minimum and maximum. So what other options do we have? Well, first of all, on the PROC means statement, we can request different statistics or change the order of the statistics in the report. I will add options to compute the mean, the median, min, max, and I will also use the option max_des equal. This allows me to specify how many decimal places I wanted to display for each of the statistics values. Like everything rounded to the nearest whole number, so I will use 0 over here. Let's take a look at the output. Notice we have these 4 statistics calculated for the entire table. But what if we would like to separate the statistics and calculate the values within the groups? The class statement in PROC means allows us to do that. I will use the class statement and I provide the variable blood pressure status. The class statement groups the data. So we will calculate the statistics for each unique value of the BP status. The class statement doesn't need you to sort the data before, but by statement that we have used for our PROC print needs us to sort the data first. Class statement doesn't require sorting the data. Let us see what it looks like. Notice we have one row per BP status and the same statistics reported. By default, we also include the nobs column that tells us how many observations were there in the data for each of those values of BP status. Back in the program, I'm not limited to one variable on the class statement. I could group by multiple variables. What if I add cholesterol status and if I run this program? You will notice there is a single table created for the combination of BP status and cholesterol status with the corresponding statistics. But if I would like to look at different combinations of these class variables, in the PROC means syntax, there is an additional statement that we can use that is called the where statement. This allows us to control how the values of classification variables are used to segment the data. For example, where1 semicolon. Let us see what happens. Notice that it creates 2 separate tables. Each table uses the values from one of the class variables. So the first table represents the values coming from the variable cholesterol status. The second table segments the data based on the values of BP status. Let us look at one other example with the where statement. I could add additional values such as 0, I will leave 1, and I will add 2. What would this produce? So, when base is 0, we use 0 classification variables to segment the data. Or in other words, statistics are calculated for the entire dataset. That is what the first table represents. When base is 1, we have the two separate tables. One for cholesterol status and one for BP status. And finally, when base equals to 2, we use the combination of two variables, BP status and cholesterol status, to calculate the summary statistics. When you analyze the detailed data, you might want to create a SAS dataset that summarizes the data for further analysis. You can use the output statement in the PROC MEANS to create a summary dataset. The out equal option names the output dataset heart status. In the output statement, you can generate output statistics and name a variable to store them in. Here we are generating statistics n and naming the variable n_obs, mean into the variable col_mean, mean into col_minimum variable, same way max. And if I run this program by keeping no print in the PROC MEANS statement, it only creates the data set. See, we have the data set with statistics. Also, if I check the results, there is no results were generated because of no print option in the PROC MEANS statement. If you have any questions or doubts, please leave them in the comments below or reach out to me through the mail ID mentioned in the about section of this channel. Thanks for watching, and I'll see you in the next video.